Ethereum is a smart contract and decentralized application platform. Gavin Wood is a co-founder and director of development of Ethereum. Gavin, welcome to Software Engineering Daily.
Thanks, Jeff. Good, nice to be here.
Software Engineering Daily has done a few shows about Ethereum, but I'd like to start with your personal explanation of what Ethereum is.
Sure. It's always a difficult one to explain, but I think, of course, from the one angle, it's a blockchain. It's probably the most general blockchain out there. It involves a Turing-complete state transition system, which basically means that the transactions on the chain can invoke code, which can do pretty much anything, like general-purpose programming languages. But another way of thinking about Ethereum is as a sort of giant decentralized computer. The code within the computer is kind of bundled into objects in much the same way as an object-oriented execution environment. But it comes with a number of guarantees, things like atomicity, synchronicity, immutability of the code, and provenance of the caller within this message-passing object-oriented environment. So, yeah, I doubt that's very much more clear to many listeners, but in some sense it's a blockchain-based computer.
Well, we'll clarify things eventually. Ethereum allows for development of distributed applications, or dApps. What is a distributed application?
So, normally when we think of applications, we think of specific computers that they run on. Especially in terms of the infrastructure, we typically imagine servers in the background coordinating between clients, recording data, archiving it, and serving it as necessary. This is where Ethereum and a decentralized app kind of differ. These applications are essentially entirely client-side, and in much the same way that BitTorrent could be considered entirely client-side, just a whole load of peer clients talking to each other and sharing things. It's kind of the same way with Ethereum. All of this stuff, all this logic that would normally go on the back end of a server is done client-side, and that's where the magic of Ethereum comes in to allow the clients to form consensus as to what's actually going on between them.
Can you give an example of a distributed application?
Sure. Probably the most famous is Bitcoin, right? So Bitcoin is fundamentally a stored account balance ledger, and really what we're trying to do is just have a database of balances and allow people to run a program which subtracts from the balance in one, assuming that it's large enough, and adds to it in another, all under the assumption that it's that this is authenticated in some way. So it's a super simple, my first sort of database program that you might write when you're 14 or 15 in school. But the important thing is that it's decentralized, and that's what makes it different.
And how do you get, what is the conceptual leap to get from how Bitcoin works to how Ethereum works?
So the key difference really is that Ethereum is programmable. So in much the same way that OpenGL programs moved from a fixed function pipeline, where we deal with very particular functions in the means to get from our geometry to a final image on the screen. Ethereum is in the same sort of sense programmable. So modern OpenGL, of course, uses shader programs, geometry shaders, pixel shaders, vertex shaders in order to get from A to B, and really allows that real breadth of possibilities. Now, Bitcoin in that way is kind of fixed function. It does one particular thing, and it's basically impossible to make it do much else. And Ethereum is programmable, in the sense that you can actually upload these sort of blockchain shader program equivalents and have them execute in this decentralized environment.
And to get into the idea of what an Ethereum distributed application looks like I also hear the term smart contract when people talk about Ethereum. Is a smart contract the same thing as a distributed application?
So I think it makes sense to look at a smart contract as an element of a decentralized application. So a smart contract, really, if we consider Ethereum as this kind of object-oriented execution environment that just happens to be decentralized and global, sitting on the internet, then we can imagine a smart contract is actually one of these objects that's sitting within this execution environment. So in programming terms, really, when we hear smart contracts, what we should be thinking of is just an instance of an object that's just in this sort of very peculiar object-oriented execution environment.
And what are the properties of, if we're thinking of a contract as sort of an object in like an object-oriented sense, what are the properties of a typical contract or of every contract?
So this kind of comes down to, what's special about the object-oriented execution environment. And the objects have properties such as the immutability of their code. So in theory, one can imagine with particular write permissions, a object would be able to alter its own code in some sense. That can never happen in Ethereum. It's sort of baked into this virtual silicon that we've coded. Another might be the permanence of the data portion of the object, so of the fields within the object. They're permanent. So normally when we think of object-oriented execution environments, we think in terms of maybe JavaScript or a program running within a C++ program running or whatever. And the idea is that when the program finishes, all the objects are necessarily deleted. And if we want them to sort of live between program executions, then we really need to back them to some store and deserialize or whatever when we run the next instance. Now that's not really the case for Ethereum. With Ethereum, it's sort of notionally always running, and so objects, their store is actually is the same thing as their fields. They just sort of are ongoing in general. Other interesting things are within the messages that get passed between these objects. We always know the address of the sender. So it's almost like we have this idea of provenance within the messages. So normally all we know is that the recipient, because that's the object whose code is now being executed, which we can generally interpret via the this or the self keyword. Well, within the Ethereum objects, when these objects receive a message, they also get another special keyword in addition to this, which is MSG, MUSC, or message. And this contains information actually concerning the message that has invoked the current code. And included in this is the notion of a sender, which is an address of another object, which actually initiated this code invocation.
Okay, so in order to do any sort of execution on the Ethereum platform, do different computers need to be operating in concert, or I understand it's a distributed computing environment, but is there capacity for a single component of that distribution to process a request in entirety?
In fact, all components, in the sense that all nodes that run Ethereum, they each process all of the requests, which in sort of blockchain terminology, transactions, in their entirety. So really it's not a case of how do we split it up as much as how do we manage if everything has to be if everything has to do everything, if all nodes have to process all transactions.
So what are the difficulties of that?
Well, scalability is the obvious one. I mean, these essentially the sorts of computational complexity, the sorts of problems that we would normally consider computers able to do, really they can't do on when sort of hamstrung by this by the Ethereum platform, because all nodes on the network have to actually be able to process all of the transactions, which means executing all of the code that everybody who wants to use Ethereum would like to do. So for this, sorry.
So what you're saying is it's the equivalent of the distributed database in Bitcoin, where everybody, consents upon every single transaction in the financial system, but in Ethereum, it's a computation system that everybody is consenting upon.
That's right. Yes.
Okay. Interesting. But there is also this notion of finance on the Ethereum platform. There's Ether. What is the importance of Ether, and describe the economics of the Ethereum platform?
So Ether is provided essentially as an anti-spam mechanism. So this is to prevent the problem of many participants each attempting to do too much computation on the platform, given that all participants of the platform must execute all computation. So the idea behind it is to have an intrinsic sort of virtual token, which would move between the validators or the miners of the network, the people who are actually processing all of the information, checking it, executing the computation when necessary, and contributing to the security of the system through this proof of work mechanism. And it's to pass these guys some form of value from the people who actually want to use the system, which is to say the people who want to operate these objects or smart contracts. Now, in terms of the economics, it's reasonably similar to Bitcoin. So for every new block, a small amount of these tokens, this sort of virtual resource, Ether, is minted. It's sort of created. It's part of the block creation process. And over time, this amount sort of reduces as a relative amount to the total amount in the system. So it actually stays the same in nominal terms, but being as there is actually a greater sort of monetary base, it represents a much smaller quantity of the overall amount.
So I think what you're getting at is that Ethereum needs to maintain a record of consensus, and Ethereum serves as an economic lever to maintain consensus. Is that correct?
So one of the ways the principal way that Ethereum maintains consensus is through this proof of work notion, which is to say, adding a new block, which is represents in computational terms the commitment of these transactions. Adding a new block, actually, there is a cost applied to this, and this is to avoid the problems of reduced consensus, where multiple participants are each propagating different versions of what they consider is the consensus, is the transactions that have been executed. And the Ether comes into it by basically being this value that people are committing their resources to get. So the resources in this case are computation. So similar, this proof of work idea is similar to Bitcoin, where there's an algorithm that generates a pseudo-random number, and one has to find the input such that the output is some particular restricted value, in this case that it must be a sufficiently low value. And in order to compensate these guys for for their efforts in sort of solving this cryptographic puzzle, they're provided with this token, this ether token, and the ether token one would hopes at least would be exchangeable for some amount of real value that will pay these guys electricity bills.
Are there any notable differences between the Ether mining system and the Bitcoin mining system?
I suppose two big ones. The first is that with the Bitcoin mining system, transactions must be checked, but the execution of them is relatively trivial. And in some sense, because the root of the new state does not need to be actually archived into the blockchain, it's not actually necessary to go through the full computation stage, at least potentially. The second is that with Ethereum, the mining algorithm is somewhat different in that we've tried to engineer it to be as resistant to hardware optimizations as possible. So we've essentially taken a GPU. In this case, we looked between the two major vendors and attempted to make an algorithm which ran reasonably quickly on both and yet wasn't susceptible to becoming substantially faster should a custom piece of hardware be made. We relied to a large extent on memory bandwidth.
Okay. So this seems useful in preventing the type of race that occurs in Bitcoin, where you just have these computers that are getting incredibly hot and wasting all this energy in order to keep up in terms of mining. If that's correct.
Yeah, that's right. I mean, in Bitcoin, they got this problem. Well, some consider it a problem, the ASIC problem, which is these are custom chips designed purely to do SHA-256 hashes and look for low values, which is essentially the problem of Bitcoin mining. So we end up with warehouses dedicated to these ASICs and pumping out vast amounts of heat, looking for a completely pointless piece of computation. So Ethereum's really actually not very different in the fundamental sense. We're still essentially giving people reward for doing useless computation, but at least it's going to be or we hope it will be a reduction of the actual amount of money spent actually making new hardware to do useless computation.
Right. So from the standpoint of a developer who wants to build something on the Ethereum platform, how do you get started?
So there's a substantial amount of documentation out there, linked mainly from the Ethereum website, the wikis. The basic steps that one would take would be to download a client. We've got a few. Depends kind of which language you're most happy with, which sort of installation style you're most happy with. Python supporters would probably be happiest with the PyEth tools set of programs. There's also the Go client and the C++ client, which are more or less at feature parity. So you take a client, you'd run it, and this would give you a sort of a JSON RPC interface with which you could start actually using the Ethereum system. On top of that, we have a JavaScript sort of wrapper for this JSON RPC, which provides, when executed within a JavaScript environment, provides a lot of nice stubs to really get started with creating objects in the Ethereum environment and actually executing their methods.
Is there a Hello World equivalent for the Ethereum platform?
Yes, it's actually on the website. So just going to the website and it will basically give you a step-by-step tutorial of getting the client, running it, and making the first contract.
So how does the development experience compare to a modern web development stack? Like in terms of the types of applications that you want to write or the development experience?
Um, there are similarities, certainly in terms of the user interface components, so the very sort of top of the stack. HTML, CSS. One can use frameworks like Meteor, which actually work really nicely with our code. On the sort of more bottom layer of the stack, so when we're thinking, database, especially back-end databases, when we're thinking of technologies like Node, really it's completely different, and in many respects, really you've got to kind of think about what it is you're trying to achieve with your application in a kind of a different way. It kind of requires a re-examination in many respects, because you have to understand that there doesn't exist this sort of all-powerful authority server sitting there that you have control over, where you can stick all of your code, even some heavy lifting code potentially, and have it deal out the answers, so to speak. Really, it requires some sort of playing around with game theory to some degree in order to understand that how different peer interactions could have consequences that you wouldn't normally consider when doing server-based logic.
Can we talk about an application that somebody's built on Ethereum that has really exemplified what the platform can do?
Sure. So let's think about the Augur project, which is trying to build a prediction market on Ethereum. So a prediction market is essentially a market that deals rather than in objects or services, but in facts. So the idea is that you make a statement, and we can attach a market to the statement. And for simplicity, we just say the statement is either sort of true or false. And what it allows us to do is to attach an economic process to the determination of validity of a statement. In real terms, what this means is that the people who are able to determine the overall validity, which we assume at some point in the future will be available for all to know and agree upon, those who are able to correctly predict what the validity of a statement will be able to make money. And those who are incapable of predicting, who actually predict the incorrect answer, will actually lose their money to the others. And
so why is Ethereum a good platform for the prediction market of Augur to be built on?
There are a number of reasons that make it good, but I suppose the main one is that prediction markets are not are in some parts of the world frowned upon, and Augur have in wanting to address markets in parts of the world where it's difficult to operate prediction markets, have used a decentralized system, Ethereum, in order to circumvent that possibility, since they themselves won't be operating it, but rather the essential aspect of the operation will come from the users of the market themselves.
Interesting. So this is are you saying the benefit is to be able to distribute and evade policymakers who might prevent the running of the prediction market?
So I think it's in some senses it distributes the legal responsibility to the users rather than a particular operator.
Interesting. So is Augur running successfully? Have there been predictions made on it?
I believe they have they're currently at the sort of testing stages, so I believe they have they certainly have a working design. I think they have a working prototype, but it's not yet live.
Do you have any idea what the bottlenecks are to them getting it live?
I think probably. I can guess. I think probably it's a case of making sure that their logic doesn't have any flaws. And this doesn't mean, bugs in the typical sense, but rather sort of game theoretic flaws that would allow a participant to, in some sense, undermine the coherence of the system.
Right. And speaking of those types of bugs, has Ethereum had to cope with any of those types of things?
The main bugs Ethereum's having to cope with and that have sort of come up in the past are a sort of niggly consensus issues. So these are the instances where multiple implementations actually differ over an interpretation of the formal specification. So normally this isn't such a huge problem for most projects, since there's only a single implementation. So unless it sort of disagrees with the specification in a way that makes it unusable, then it's just a bug fix later on. For us, it's a major issue, since it would a disagreement over the formal specification actually on a live network would result in a fork, which essentially means different transactions are being sort of committed to different people's idea of what the actual final state is, and that can lead to double spend attacks.
Ah, okay. So let's talk some about the Ethereum scripting language. First of all, why does a system like this is a naive question, but why does a system like Ethereum need a scripting language, and where does the scripting occur?
So the scripting language, which it's actually a reasonably old name now. When I came aboard, I sort of realised that this wasn't a scripting language in the normal sense of the word, but rather it was a specification for a virtual machine. So this is really an instruction set. And the Ethereum, this instruction set comes from the fact that we want to make Ethereum general purpose. So it makes sense to have a Turing complete set of instructions to allow whatever language, high-level language that people want to use to be compiled down and actually work.
Okay, and what was the specification for that language design?
The design, well, the goals that we actually wanted with the design were to provide something which was at once general, minimal, and that addressed the specific problems associated with cryptographic operations. So, in this setting, what we see is, for example, we don't have shift operators in our shift operations in our language, since they can actually be expressed by multiplies and divides. We don't have small types of integers. So all of our arithmetic works on the basis of 256 bits, which just so happens to be the size of the private key in ECDSA, and the SHA-3 hash, which we use throughout Ethereum. So this basically, we've designed this virtual chip, this virtual machine spec around 256-bit words.
Okay, and so one of the major contrasts between Ethereum and Bitcoin is that Bitcoin's scripting language is not Turing complete, and this is a very deliberate decision by the author of Bitcoin, Satoshi Nakamoto. But Ethereum has a way around the problems of Turing completeness that Satoshi was worried about. Can you describe why Satoshi was originally worried about Turing completeness in the Bitcoin scripting language, and how Ethereum fixes that?
So, Turing completeness opens up a problem, which is the commonly known as the halting problem. So this is the notion that in order to actually even determine whether a program will halt or not, requires an unbounded amount of resources. Now, there are a number of ways around this. One of them is to restrict the language, which is what Satoshi did with the design of Bitcoin. So the language is restricted to a very small portion that isn't, as a whole, Turing complete. And what this allows us to do is actually bound the amount of computation that can be possibly done in a Bitcoin transaction. Another way around it is to actually just add a limit, just hard code a limit onto the amount of computation that can be done, and just measure it. And when that is up, when that limit runs through, then the computation is finished, regardless of what state it's in. Now, this is essentially what we've done, except what we've also done is allow the person who wants to run the computation, who's submitting the transaction, we allow them to specify their own limit as long as they pay for the resources required by that limit upfront.
Okay. So to clarify, Ethereum does solve the halting problem.
It sidesteps it.
It sidesteps it. Okay. Very interesting. Okay. Are there any potential edge cases that could break the Ethereum network?
No, well, there are the obvious edge cases would be things like consensus flaws, where the virtual machine on one implementation goes one way and on another goes another way, and that would represent probably the single biggest problem.
So this is a fork that you're talking about.
Yeah.
What are the consequences of a fork, and how can a fork occur?
So a fork occurs generally when there's a bug in one or more implementations, which could include old implementations that just never sort of got fixed, and that other machines were still sort of happy to accept. But generally is simply a case where multiple implementers have disagreed on the interpretation or of the specification, or worse, when the specification itself was legitimately ambiguous. And so they're both correct in their different implementations.
How does Ethereum coordinate computation across the network?
So this comes down to sort of multi-stage process. In the first stage, the operations that the participants of the network wish to execute on their objects, essentially just a method call, a bunch of method calls, each one cryptographically signed so that it's very clear, objectively clear that it's valid, are collated, and they're distributed around the network. So it's very much similar to a peer-to-peer network with just flooding the peer nodes with these operations. We call them transactions. Now, every roughly 15 seconds, a new block is created. Now, this block is special in that it contains a very difficult to create but easy to prove what we call proof of work, or actually it's just a very simple number. It's a 256-bit number, which, when hashed along with the rest of the block, provides a sufficiently low value, which generally means that you've spent about 15 seconds of the network's total compute power determining. And the idea is that these blocks, difficult as they are to produce, contain a number of things. One thing is a bundle of these transactions, so a bundle of operations that are cryptographically signed, so that we have a provenance, right? This allows us to determine what the message sender address is, and the what we call the final state. So this is basically like if we use a Merkle tree in order to collate the entirety of the Ethereum computer's state. So this is the state of all of the objects in its execution environment, plus one or two other attributes. If we collate all this, we get a single 256-bit hash. And if anything ever changes, this hash will change. Now, a Merkle tree has a few extra interesting points as well, but that's the key thing. And this hash gets included in the block. Now, the block then would get dispersed around the network, and all of the nodes would check the block, make sure that they also agree that doing these transactions resulted in this final state, the hash that's included. And if they do, then they accept the block as being the sort of the best, the new state, the thing that the computer has moved on to. And then what they do is they take the transactions that have still yet to be done, and try and make a new block. And eventually one of them will do, and the whole process will repeat.
What are the most difficult distributed systems challenges that you had to overcome when you were building the Ethereum system?
A number. So possibly the most difficult aspect of this was actually the peer networking portion, which is essentially just trying to make sure that all participants of the network have a roughly fair chance of receiving this new block. So trying to synchronize between the participants, and also in when they create a new block, if assuming that they have solved this cryptographic puzzle and they've actually managed to commit these transactions, to actually get it out in again a roughly fair way, so that no other participant, no other node on the network stands a fundamentally better chance of receiving the reward. Now, it's because we are using such a blunt consensus system. Like, we're not trying to partition nodes up to make them any different. Everything is symmetrical. We actually circumvent an awful lot of issues that would normally you'd expect with distributed systems. And rather than the price that we have to pay for this is to be sure that in sort of microeconomic terms, there is no way that any one participant can sort of game the system and receive a greater reward, or in some way have a chance of maybe reorganizing transactions after the fact, and which would lead to double spend attacks. So there's a lot of thought gone into the network layer to prevent things like network partitions happening, flooding attacks, so maybe a Sybil attack where a single attacker actually controls an awful lot of the nodes on the Ethereum network, and just generally to prevent any participant with a reasonable amount of resources from disadvantaging everyone else.
So on this show, we talk some about the cap theorem, which is implies that you can only pick two between consistency, availability, and partition tolerance. Does Ethereum fall under any specific constraints of cap?
So, in essence, yes. Ethereum is not in the slightest bit partition tolerant, which is to say, if the network were partitioned and recombined at some later date, one or the other partition, one of the other participants, the participants of one or the other partition would potentially have their operations reversed.
I'd love to hear about the engineering culture of the Ethereum project. I think you're sitting at the Ethereum offices right now. What is the ethos of Ethereum, and how does that manifest in the culture? Because it's a very unique product that you're building.
Yeah. So sitting in the offices, actually, being a very decentralized organization, sitting in the offices is can sometimes be quite a lonely experience. But yeah, by and large, our ethos is probably determined partially by the fact that people have generally come to the project out of their own desire, So most of the people who are part of the project now are were in some sense interested in a personal way before sort of being hired. The ethos kind of reflects that. So there's a lot of people work kind of odd hours. People tend to do the parts of the system that they want, and this includes even instances where people sort of have a 9 to 5 bit of the system that they work on, and then kind of after hours also work on the project, but in maybe some other sense that they actually find personally very rewarding.
Okay, so there are people that I've talked to from the Bitcoin community, and they admittedly have a vested interest in Bitcoin, but at the same time they express a distrust of Ethereum, and that sense of distrust has been so strong from some of them. I kind of bought into that distrust, and I investigated it, and I actually did an interview with your colleague Stefan Twal, and I asked him about some of the biggest criticisms, and he had good answers to everything. Like I didn't feel like, walking away from that interview, I didn't feel like as much of the skepticism that I had encountered from some of the Bitcoin community was really warranted. So, but from your point of view, what are the parts of the Bitcoin community that are skeptical of Ethereum? Why are they skeptical?
I guess this comes down to human nature a little bit. I think I was personally it was an interest in Bitcoin that eventually sort of took me to Ethereum. It was less of an interest in Bitcoin as an economic experiment, less of an interest in it as a currency, but much more in the underlying technology and just wanting to understand how it works. And I think to some degree there might be a correlation between the people who are sort of interested in Bitcoin as a currency. Perhaps they are vested. I don't know if all of them, but I mean maybe to some degree. And the people who are interested in Bitcoin, sort of Bitcoin in the portion of the Bitcoin community that are primarily interested in Bitcoin as a piece of technology. And I think, when you start thinking of Bitcoin as a currency, then you become quite maybe you become naturally worried perhaps about other sort of similar currencies, if you like, similar projects sort of taking over, because whereas the technology is just universal. Currencies are very particular, and currency, it's almost like a zero-sum game, right? Whereas technology, contributions to one project in roughly the same technology space will benefit other projects as long as everything remains open source, which at least in our case it does. So I think we've kind of got two groups of people to some degree. We've got the sort of diehard technologists for whom the currency really is irrelevant. The project to a large degree is irrelevant. It's really just about looking at cool stuff and solving cool problems. And then you've got the other sort of participants who are much more focused around building a single global currency, and what these guys perhaps kind of see as a threat would be any other kind of potential single global currencies that could take potential or steam away from the movement. And so I don't know, maybe that's where it comes from.
Right. But I mean, as I understand, like Ethereum and Bitcoin, it seems like they're contributing to growing the pie, and rather than it being a zero sum thing, it's more of a positive sum thing. Like you can, as I understand, there are synergies between Ethereum and Bitcoin.
Yeah, I absolutely agree. I mean, and I think there are many in the Bitcoin sphere that also agree. Obviously, very few people are sort of one or the other. And yeah, I think it's a very sensible way of looking at it. I think the entire ecosystem is very young, and I think as we go over the next 3, 5, 10 years, then we'll see the pie grow anyway. But nonetheless, I it's the only way that I can really explain to myself why some people are so sort of kind of ideological over the idea of there being a single currency, and that no others really should be.
Yeah, I mean, I think maybe I guess the big, a somewhat sensible fear that I see from people is like they're afraid that if the Bitcoin community or the cryptocurrency community gets too bifurcated or too split up between different things, and then they all are spread too thin, and then they all fail, it might make the world shell-shocked and just give up on Bitcoin and cryptocurrencies altogether.
Yeah, I mean, I think that really is a much more kind of social view rather than a technical view.
Yeah, because it's a fundamental technological advance. It's not something you can ignore.
Exactly. I mean, the thing is, nature, technology, society ultimately will favour the more efficient, the better working systems. And as long as these guys accept that, the blockchain, whatever, Bitcoin, whatever you want to call it, is fundamentally a better way of solving problems, or at least a certain set of problems, then there can be no, the cat's out of the bag. There can be no putting it back in. Something will succeed. Probably a bunch of things, and so I really don't think there's a major issue in bifurcation of community or anything. Mm-hmm. Technology is shared; it's all open source. I don't really think it's an issue.
So we did a show about Bitcoin sidechains, and sidechains are this way to get additional functionality tacked on to the world of Bitcoin. What do you think of Bitcoin sidechains? Is this a way that they could potentially just build like Ethereum functionality off of Bitcoin?
I can't say I know a vast amount of the internals of the project. I read the white paper, and certainly with some caveats, it could be used to extend the some of the problem, some of the what would we call it? Extend the functionality of Bitcoin to some degree, but I think there are still a number of issues to be solved, especially in terms of the security incentivization. So one of the reasons that Ethereum, because we looked for a little while at like maybe Ethereum could be a blockchain, or maybe there could be a sort of a side chain. Maybe there could be some side chain that sits between Bitcoin and Ethereum, which would be pretty cool. But we kind of came to the conclusion that it probably wasn't possible, at least not with any substantial amount of security. The way that at least in the original white paper, sidechain works is by determining the validity of a transaction to unlock bitcoins purely by virtue of nobody sort of providing a. Essentially, it's by the depth of a transaction within the sidechain itself. What this means is that the sidechain security is the primary mechanism for unlocking a Bitcoin on the main Bitcoin chain. So if an attacker actually managed to get control of a sidechain for a sufficient period of time, perhaps by pouring in a large amount of computation resources, or buying off the miners because the sidechain perhaps doesn't have a large amount of security on it itself, then there would be a problem of the bitcoins that were locked on the main chain actually being unlocked by this attacker. So I think it can solve a class of problems where perhaps a third party wishes to have access to the transaction wealth of Bitcoin, so the liquidity to some degree, and is happy to pay for that and take on, in some sense, the burden of securing the sidechain. But for a much more sort of general decentralized Ethereum-like chain, I don't think, and maybe they'll prove me wrong, but I don't think the current technology is up to it.
Okay, interesting. That's very helpful. So what are the biggest challenges that you have encountered as Director of Development at Ethereum?
Partly staffing. Finding good people is difficult, especially within a tight time scale. Like I said, most of the people that we have come to us, and it takes a while for that. It's a relative trickle, and it takes a while to build up a substantial base of developers in that manner. Aside from that, I mean, obviously there's management of the development side, so working out prioritizations and getting the right people on the right jobs. But I guess that's really very little to do with Ethereum, and just has more to do with software development in general. I would say that actually it's easier than in other projects, or it's partly easier than in other projects because of the fact that most of the people actually, to some degree, self-organize. They understand what the mission is, and very little work has to be done to actually sort of guide people in terms of what part they should be doing next. Most people understand what the end goal is. They have a good idea about the portion of the project that they're working on, and things tend to work reasonably well.
Okay, well, that sounds like a great place to stop. Gavin Wood, thanks for coming out to Software Engineering Daily, and it's really been a pleasure talking to you. I think Ethereum is one of the coolest projects I've seen, so I really look forward to seeing future developments.
Cool. Thanks a lot. Nice to be here, Jeff.